stuffing your face for like hundreds of millions of years. Like the hot dog eating competitions. Have you seen those? Where it's just
Kobayashi.
like, yeah, dude. The way that black holes get big is through accretion, right? It's eating up mass. It gets bigger and bigger. There's a caveat to it though. Okay. You've got to take your time with your meal. That's the point. There's something called the Eddington Limit. Okay. And it says there's a maximum accretion rate before I'm eating too much. And when I eat all that much, I'm going to spew out radiation. That radiation is going to shock all of the rest of my food away. So there's a maximum limit at which I can grow.
3,000 calories a day max.
Max, right? And if you do too much, then there's no food around you.
Right.
The Eddington Limit, it's named after Arthur Eddington, who's a amazing man of science in history, also a bit problematic. From that, we get an accretion rate. It's like, how much am I eating?
Yes.
And from that, I can have a characteristic growth time scale of like how much time do I need to grow by a certain factor?
If I'm trying to gain 10 pounds or lose 10 pounds.
Yeah, how long is that going to take? Back in July 2022, JWST came online. Within 2 weeks of when the data was released, we had headlines like this from the Scientific American. JWST was seeing universe breakers. And what it was all about was there were these spots of red light everywhere. They have a lot of activity and a lot of mass. So yeah, seems like a black hole. These black holes are 100 million times the mass of the sun, right? How did it get that big? So there's two possibilities. One is you've got these light seeds. You have the first stars. These are population 3 stars. When they blow up, they're going to make a black hole. And that black hole is going to be about 100 times the mass of the sun. And so in order to reach 10 to the 9 times the mass of the sun in 800 million years, you got to be continuously eating at the Eddington limit.
I see. Stuffing your face.
You got to be in the zone.
Yes.
For hundreds of millions of years.
Yeah. Constantly.
Very improbable.
Seems, yeah.
The second possibility is there's heavy seeds, which is this direct collapse. You don't make a star. You just got a gas cloud. You get a black hole. No star needed. For that, the advantage is you can reach that high mass, but the conditions got to be perfect. Which is, again, improbable.
Right. So the idea is the light seed and heavy seed options don't pass the sniff test.
Yeah. On the one hand, you have like a black hole that is just eating max out. Second, the conditions to create that first black hole are like perfect. Okay. And the number of these little red dots that we're seeing, it just doesn't make sense.
There's too many. We're seeing so many of them. So you're saying this thing that's improbable is happening like frequently.
Yeah.